Welcome to the Deep Dive, your shortcut to being well-informed. Today, we're cutting through the noise to tackle something pretty serious in the tech world. There's this engineering excellence gap. It's real, and frankly, it's costing organizations millions. You see the symptoms everywhere, right? Global outages that just cripple things, big supply chain breaches, ransomware attacks hitting left and right. These aren't just, bad luck incidents. They're signs of a deeper systemic problem in how we're building and securing software.
That's exactly right. And while you hear a lot about, say, the next wave of AI, the sort of underlying truth is that many engineering teams, they're still drowning in technical debt, manual processes, security issues that honestly should have been solved years ago.
Yeah.
It's this persistent kind of frustrating challenge.
Yeah.
But here's what's really fascinating. Organizations that are actually getting a handle on this, tackling it systematically, they're not just dodging bullets, they're actually unlocking huge amounts of hidden value, like consistently doing way better than their peers.
How is it?
We're talking shipping features maybe 60% faster, slashing cloud costs by, say, 15%, getting security incidents down to almost zero. And look, it's not always about having some kind of unicorn talent pool. It's more about knowing exactly where the gaps are and having a disciplined way to close them.
Which is exactly why we're doing this deep dive today. The insights we're sharing come from a pretty comprehensive look at engineering maturity based on really candid responses from over 650 engineering leaders. And what really jumped out, how many leaders think they're doing great in key areas, maybe DevOps, for example.
Yeah.
But when you look closer, they're missing fundamental everyday practices.
Yeah, there's a real disconnect sometimes between perception and reality.
Totally. So our mission today is to help you pinpoint what actually matters to bridge that gap. We're going to unpack 5 critical dimensions where organizations can find big opportunities: developer experience, DevOps modernization, optimization, quality and resilience, and secure software development. Ready to dig in?
Let's do it.
Okay, so let's start with developer experience. DevX, right? At its heart, this is all about giving developers the tools, the resources, the whole environment they need to just work fast and efficiently. Seems basic, but the findings highlight some, well, surprising roadblocks.
Oh, absolutely. We found clear struggles right from the very beginning of a project, like take planning and requirements. 1 in 4 engineering leaders admitted that over 70% of their requirements, they just don't have clearly defined acceptance criteria.
70%, wow.
Yeah, I mean, imagine the rework involved, the back and forth, the sheer frustration that must cause. And it gets worse. Over half, like 54%, have seen their average scope creep go above 20% in just the last 12 sprint cycles.
20% scope creep.
Yeah.
Consistently.
Yeah, that's not just wasted effort, right? It's a constant drain on morale, on the budget, just churn.
So we're basically starting projects with kind of blurry blueprint, lots of unexpected detours. That level of uncertainty must just create friction for developers every single day.
It really does. And that friction pops up again when they just need to find information. Get this. Only 21% of engineering teams have an automatically updated software catalog.
Only 21%.
And maybe even more concerning, almost a third, 29%, have no software catalog at all.
None. How do they even function?
Well, it's a struggle. It's not just inconvenient. It's like a fundamental breakdown in how the organization shares knowledge. It's like trying to find a specific book in a giant library with no index cards, no signs, nothing. Engineers end up reinventing the wheel or they just get lost. It really stifles innovation.
That library analogy really hits home. And I bet that friction extends to their actual, digital workspaces, too.
You bet. Think about developer environments. Only about a third, 34% of teams can quickly spin up pre-built environments in the cloud. And maybe even more telling, 67% of leaders say their developers cannot build and test a dev environment within 15 minutes.
Not within 15 minutes. It's a huge chunk of time just getting ready to work.
It's a massive productivity drag. Every minute fiddling with an environment is a minute not coding. And then there's the daily grind, the hygiene. Almost 2/3 of leaders, 61%, say code reviews take longer than a day.
More than a day for feedback.
Yeah, and 35% don't consistently follow a branching strategy. You can imagine the integration nightmares, the merge conflicts, chaos. And finally, what about learning? Growing skills. Only 19% of leaders say they have a structured curriculum for upskilling their engineers.
Only 19%. In a field that changes so fast.
Exactly. It's basically a recipe for skill stagnation.
So, okay, you've painted a picture of lots of small inefficiencies, frictions, delays. What's the cumulative hit? What does this cost?
Well, the cost of not investing in how your developers actually work day to day, it's way higher than most people think.
Right.
Let's take an organization with, say, 1,000 developers. If they adopt good DevX practices, they can speed up onboarding by 40–60%, just that improvement alone. It translates to annual savings of $1 million to $1.4 million just from onboarding faster.
$1 million to nearly $1.5 million just from smoother onboarding.
Yep. It's a direct return on making engineers more efficient, reducing that constant cognitive load they're under.
That's a really compelling financial reason to improve engineers' daily work lives. Now, building on that idea of friction, let's look at how it extends to actually getting the software out the door. Next up, DevOps modernization. And this isn't just about buying new tools, is it? It's more strategic.
Exactly right. It's about fundamentally transforming how software gets built, delivered, and secured. And, even though DevOps is everywhere as a buzzword, many organizations are still stuck on surprisingly basic things.
Like what?
Well, take the build process. Over a third, 36% of organizations don't have standardized build pipelines. Imagine like every worker on an assembly line designing their own wrench for every single task. That's the kind of inefficiency. And while, 56% run all their test cases, only 17% select those tests intelligently.
Meaning lots of wasted test cycles.
Yeah, running redundant tests or tests that aren't actually effective. And maybe more worryingly, 55% of build pipelines aren't gated properly, or the gates they have just aren't enforced. So bad code can just slip right through into later stages.
Okay, so despite all the talk about automation and DevOps, there's still a surprising amount of manual work and inconsistency baked into these processes.
A huge amount. When you look at deployment automation, the reliance on manual stacks is pretty stark. Nearly 1 in 5 teams still don't have standardized deployment pipelines. Think about that. And get this. 50% of application code deployments, 64% of infrastructure code deployments, and a whopping 69% of database changes. They still rely on manual steps.
69% of database changes are manual. That sounds incredibly risky.
It is. It's a massive opportunity for human error, for slowdowns, for burnout. Plus, 36% of teams aren't using modern deployment strategies like rolling updates, canary releases, blue-green. Those are key for minimizing risk during release. And 76% don't use feature flags effectively or don't have a process for them, which means less flexibility and much higher risk with every single deployment.
Manual steps, old strategies.
Yeah.
It really does sound like a lot of orgs are operating with kind of one hand tied behind their back, especially when things go wrong.
That's a good way to put it. And when things do go wrong. For automated rollbacks, 44% of organizations still rely on manual rollbacks for failed deployments, and 43% base the decision to roll back on subjective feelings rather than actual data. That just delays recovery time, the MTTR.
Subjective evidence for rollbacks. Yikes.
And critically, let's talk security and deployment. 43% of teams don't store secrets in a centralized secrets manager. And this one is truly shocking. 1 in 10 store secrets and even PII, personally identifiable information, in plain text, right there in their deployment system.
Plain text PII, that's negligent.
It's a massive flashing red light for any attacker, just waiting to be exploited.
Okay, so beyond the obvious security nightmare fuel, what's the actual tangible cost of all this manual effort, this inconsistency in DevOps?
The potential savings here are really significant. Again, think about 1,000 developers. If about 23% of their time is eaten up by manual build and deployment tasks, which is pretty typical, organizations can save between $6 million and $9 million annually just by cutting that manual toil by 25–40%.
$6 to $9 million a year just by automating more of the DevOps pipeline.
Exactly. It's a really clear path to substantial efficiency gains, faster delivery, and it hits the bottom line directly.
Those numbers are hard to ignore. Okay, let's shift gears slightly. Let's talk optimization. This is all about making sure every dollar spent on cloud, every hour of engineering time really counts, getting maximum value. This feels like where metrics really matter.
Absolutely. And it's an area where, frankly, many organizations are just leaving money on the table because they don't have good visibility or control. Look at cloud costs. Only 2 out of 5 engineering leaders actually track cloud spend by project, team, and department.
Only 2 out of 5, so most don't know who's spending what.
Pretty much. And even more striking, only 12% say their efforts to cut cloud costs are automated. This points to a huge amount of potential waste just drifting away, not being actively managed.
Yeah, it's like having a leaky faucet, like you said, draining the bank account, but you don't know where the leak is or how to fix it automatically.
Perfect analogy. And it connects directly to a broader issue, this gap in metrics and insights. Only 17% of engineering leaders say their teams analyze key metrics daily or even weekly.
Only 17% are looking at metrics regularly.
Regularly, yeah. And nearly half, 50%, report that service level objectives, SLOs, and error budgets, they aren't defined or calculated for any of their services. And only 13% say SLOs and error budgets are automatically calculated and actually used to, say, gate deployments, stop a bad release.
Without that data, how can they possibly make good decisions about resources or improvements?
It becomes incredibly difficult. You can't easily spot bottlenecks. You can't measure the impact of changes. You can't make informed calls about where to invest engineering effort or cloud resources. It's kind of flying blind.
It's really fascinating how much value seems to be locked up, just waiting, because orgs aren't tracking or automating these really critical parts of their operations.
The potential savings are substantial. Let's take an organization spending, say, $35 million total on the cloud. Maybe $5 million is marketplace stuff you can't easily optimize. That leaves $30 million in optimizable cloud spend. By putting in place best practices for cloud optimization, they could realistically save $3 million to $4.5 million a year.
3 to 4.5 million, that's 10–15% savings.
Exactly. It just underscores that having granular visibility and automating cost reduction efforts, it unlocks really significant financial benefits. It's about treating cloud like a real budget, not just an infinite resource.
Definitely food for thought. Okay, moving on to quality and resilience. This is all about making sure systems are robust, right? That they can handle tough conditions, bounce back quickly from problems. This feels foundational for user trust. If this isn't solid, nothing else really matters.
You've got it. And the findings on quality testing show some pretty big shortcomings. 60% of engineering leaders say their test or staging environments do not match production.
60% don't match prod. That's the classic works on my machine problem waiting to happen.
Exactly. It's a recipe for surprises when you go live. And a quarter, 25%, say less than 30% of their features even have test plans. Only 1 in 5, just 20%, have more than 90% unit test coverage. That's considered table stakes by many high-performing teams. And maybe most telling on the automation front. Just 10% say functional testing is fully automated.
Only 10% fully automated functional testing. So that means tons of manual, slow, error-prone testing is still the norm. Or maybe testing just isn't getting done.
It's likely a mix of both. It means you're not catching bugs early, you're not preventing them from reaching production effectively.
So it sounds like many organizations just aren't set up for that proactive approach to quality. They're more reactive.
That hits the nail on the head. And a truly proactive approach to resilience involves things like chaos testing. Intentionally breaking things in controlled ways to see how the system reacts, building that fault tolerance muscle. Yet, 2/3, 56% of engineering teams don't use chaos testing at all. And only 13% have actually integrated it into their regular development lifecycle.
So most systems aren't really being tested for how they'll handle real-world stress or unexpected failures.
Largely, no, not proactively. And then look at incident management. When things inevitably do break, more than half, 52% of engineering teams lack key tools to even support good incident management. 1 in 10 teams doesn't even have a formal incident management process defined. And maybe most critically for learning, only about a quarter, 27%, say they conduct blameless postmortems for all their incidents.
Only 27% do blameless postmortems for everything. So crucial learning opportunities are just being missed again and again.
Over and over, you're not fixing the systemic issues.
So, okay, forget just user frustration for a second. What does this lack of quality, this lack of resilience, actually cost an organization in dollars and cents?
This is where it really hits home. Again, let's use our 1,000 developer org example. If their total annual cost of downtime is calculated at, say, $5.4 million, implementing measures to improve quality and resilience could cut that downtime cost by 40–60%. That translates directly to $2 million to $3 million in annual savings.
2 to 3 million saved just from reducing downtime through better quality and resilience.
Exactly. These aren't just tech problems. They directly impact revenue, brand reputation, operational stability. It really makes you ask, can organizations afford not to prioritize these fundamental building blocks? It's about designing systems that expect failure, not just react when it happens.
That's a powerful case. Okay, final dimension. Secure software development. You hear it all the time. Security needs to be baked in, not bolted on. Truly mature engineering means security is part of every single phase.
It's absolutely critical. Non-negotiable, really. Yet, we found pretty persistent gaps here, too. Take integrated security and governance. 38% of engineering leaders say their build pipelines are not gated with security scans.
Not gated, so vulnerabilities can just sail right through the early stages.
Easily, making them harder and more expensive to fix later. What's more, 45% say it takes longer than 7 days on average to fix high-severity security issues. And this is alarming. 1 in 10 leaders admitted that high and critical severity bugs are not fixed before release.
Wait, releasing with known high or critical bugs, that seems like asking for trouble.
It's a significant risk exposure, a ticking time bomb, frankly, especially as you mentioned earlier with supply chain security being such a huge focus now.
Right. Understanding what's actually in your software seems more critical than ever.
It is. Which brings us to the Software Bill of Materials, or SBOMs. Knowing the exact ingredients of your software isn't optional anymore for security and compliance. But only 11% of engineering leaders generate SBOMs for all their software artifacts. And over half, 57%, generate SBOMs for less than 30% of their artifacts. That's a massive visibility gap, a huge blind spot about what you're actually deploying.
So most organizations don't really know all the components they're running in production.
Not comprehensively, no. And finally, look at security training for developers. While over half, 56%, do get trained annually or semi-annually on security best practices, which is good. Nearly a quarter, 23%, are never trained.
Never trained on security.
Never. That leaves a big chunk of the workforce potentially unaware of current threats or how to write secure code.
Okay, so beyond the massive, potentially catastrophic risk of a breach, what's the day-to-day productivity cost of these security gaps? All the manual checks, the rework.
There's a real productivity hit. For those 1,000 developers, if you can reduce manual security tasks and the time spent fixing vulnerabilities by 20–25%, which you absolutely can by integrating security earlier, automating scans, shifting left.
Yeah.
That translates to $1 million to $1.25 million in annual savings,
Yeah.
just in recovered productivity.
$1 million to $1 million a quarter.
Yeah.
Just from making security more efficient.
Exactly. And that doesn't even touch the immense potential cost savings from actually preventing a breach or the damage to your brand and customer trust if one happens. It really shows that security, when done right, isn't just a cost center. It's a productivity enabler. It's about weaving security in, not having it be a painful gate at the end.
Okay, wow. Let's try and tie this all together. We've walked through 5 really critical dimensions: developer experience, DevOps modernization, optimization, quality and resilience, and secure software development. And it's become crystal clear that significant gaps across these areas, when you add them up, are costing organizations millions every year. Massive amounts. But the flip side is also clear. There's huge potential for savings, for gains in speed, productivity, resilience, just by tackling these areas systematically.
Absolutely. The big takeaway here, the practical implication is that achieving real engineering excellence, it isn't just about, avoiding bad headlines or disasters. It's fundamentally about unlocking substantial financial benefits and operational advantages. It really drives home how investing in these foundational practices pays dividends across the board: faster features, lower cloud bills, much stronger security.
So this really brings up a crucial question for you listening right now. How do you and your organization measure up against these kinds of benchmarks? Which of these 5 dimensions really resonates with the challenges you're facing today? Maybe take a moment to think. What 1 or 2 areas might offer the quickest path to unlocking some of that hidden value in your own operations? Perhaps the very next step is to get an objective assessment of where your organization truly stands on these vital aspects of engineering maturity.